Welcome to PV Online Physics. Today we're going to take a look at graphing constant velocity, and we're going to begin by looking at position time graphs. As the title suggests, you're going to look at where an object is at a given point in time. So since we're going to be looking initially at constant velocity, that simply means that you're moving at the same speed over a certain time interval. So if you were on the freeway going 60 miles an hour, that means that after 1 hour you will have traveled 60 miles. After 2 hours, 120 miles, and so on. So imagine, if you will, we're going to start at our home. So I'm going to say when I start my stopwatch, I'm at position 0. So we could put a dot, whoops, at that point. I'm sorry, I'm having a hard time getting these points. Well, let's see if we can do the next one. So that means that I would have a dot at the origin, and then let's say that we're traveling 2 meters every second. So since time is on the x-axis at 1 second, I know that I'm at 2 meters. So on the y-axis, you can see that the position's on the y-axis, so I'm going to put a dot at the 2 meters and the 1 second. That's not quite perfect, but you get the idea. All right, if I'm moving at a constant speed, that means after 2 seconds, I will be at 4 meters. I just am missing that spot a little bit. Here, let's see if I can move this up a hair. All right, and then at 3 seconds, I would be at 6 meters. There we go. I'm moving the graph to the points. All right, so at 3 seconds, I'm at 6 meters. And then at 4 seconds, I'm at 8 meters, and so on and so forth. And so hopefully you get the idea that you're traveling 2 meters every second. Now I'm going to go ahead and put a line through my points to show you the shape of a position time graph when you're moving at a constant speed. Now, as those points are connected, you can see that the shape is a straight line. And that's what it's going to look like anytime you're moving at a constant speed. You'll have this straight line. Now, we can determine the velocity of the object simply by looking at that slope. Since the slope is positive, we would have a positive velocity. All right. Now, what do you think this next graph is going to look like? I'm going to sketch a red line, and I want you to think about what it tells you about the object's motion. Okay, so take a look at that red line. You'll notice that the line is horizontal. Now at t equals 0, where is the object? And the object is approximately at 6 meters. At a time of 1 second, the object's still at 6 meters. And at 2 seconds, it's still at 6 meters. So what does that tell you about the object's motion? And hopefully you realize that this means this object is stopped or at rest. It's not moving. Now compare that to our original one, and our original one was moving at a constant velocity, and we would have called it a positive velocity, because we're going to learn that there's going to be a little slight difference between velocity and speed. Velocity is a vector, which simply means that direction is going to count. So this is a constant positive velocity. Next, I'm going to draw a green line and see if you can describe the motion of what's going on with the green line. Okay, we have our green line. You take a look at it, and it's definitely got a slope. It's definitely a positive slope. That means that we're going to have a constant positive velocity because the slope's not changing. So what's the difference between the blue line and the green line? And you can see that the green line's steeper, which simply means that it's going to have a faster constant velocity. So this is going to be a fast constant speed. All right. And then I'm going to use a purple line for our last example and see if you can figure out what it tells us. Okay, I cleaned up a few of the other lines so it wasn't so sloppy. And now I've added this purple line. And what do you notice? Notice the difference between our original line and this purple one. There's a couple huge differences. One is the starting point. I would say that our original blue line started at the origin and we were moving away. Compare that to the purple line where our object is starting way ahead in front of the origin, and this time instead of going away from the origin, it's actually moving back towards the origin. So this purple line represents a constant velocity, but this is going to be a constant negative velocity. So from our position time graphs, there's all kinds of information we can get from it. We can determine as soon as you see that it's a diagonal line that the object's moving at a constant velocity. With the slope, whether it's positive or negative, that's going to tell you the direction that the object is moving. And then with the steepness of the lines, that will tell us how fast or slow it's going. The more steep, the faster the object is going. Now, I would really suggest that when you watch these videos, make sure you take notes and keep a notebook so that you have them to refer to. It's one of those things where it might make sense as you're watching them, but then you'll eventually forget it. So it's really good to have it on hand when you're doing your assignments. See you next time.